Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Sridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subject. Today in our playlist of basic electrical engineering and class 12th physics in chapter alternating current circuits, we'll study the concept of average value of alternating current and will understand how DC equivalent value for alternating current is obtained for equivalent charge transfer capacity. We'll also learn what is significance of average value in our study. So let's start. A standard sinusoidal wave is as shown in this yellow highlight. This starts from instantaneous value 0 at time 0 condition and increase in positive direction in a non-linear manner. The simplest trigonometric and mathematical expression for instantaneous magnitude of voltage or current is expressed as shown here. Here Vm and Im are respectively peak magnitude or amplitude of voltage and current, and omega is angular frequency. When omega is multiplied with time, it become an angle measure called as argument, and as time changes, omega t changes, trigonometric value of sin omega t also changes, and sin omega t when multiplied with amplitude will give us instantaneous value of voltage and current, and this instantaneous value increases in positive direction initially at a faster rate than the rate of increase gradually decrease and it attain positive peak, and after that it start decrease initially at slower rate than at a faster rate, again attain zero magnitude and current change its direction, voltage change its polarity, and just like positive half cycle, negative half cycle is produced by magnitude variation, and now this cyclic variation repeat itself. Now the question arises, by what magnitude we should define this voltage or current variation? When a sinusoidal variation got a non-zero instantaneous value at time instant 0, it may be either positive or negative, then time expression of that instantaneous current or instantaneous voltage in general mathematical notation is expressed in terms of amplitude. Here Im is amplitude of current and Vm is amplitude or peak magnitude of voltage variation. For this expression we use omega, which is angular frequency in radian per second, and this theta indicate phase condition of sinusoidal variation or is related to T0 instantaneous magnitude. Now in this variation, the peak magnitude or amplitude position remain for a very brief small time duration, or we can say peak position is instantaneous position. In a voltage signal, this peak magnitude or amplitude is relevant when one has to decide voltage withstand capacity of insulation used in any electric installation or device, or one is concerned with shock conditions or risk involved in electric shocks, then such peak magnitude or amplitude of voltage is relevant. Similarly, peak current is relevant only when one is calculating short time current rating of sensitive devices. Otherwise, peak magnitude or amplitude is irrelevant in our alternating current studies, and in place of this peak magnitude we'll use some more important measurement of this time varying quantity such as average value or root mean square effective value. In direct current circuits, one key use of electric current may be charge transfer. Now for determination of charge transfer capacity of alternating sinusoidal current, which have time varying both magnitude as well as direction, we have to compare this alternating current with a steady DC current, and when the magnitude and direction of alternating current is variable, the rate of charge transfer per unit time also varies, and it is a sinusoidal trigonometric function of time as Im sin omega t. So at different time instants, due to different value of instantaneous current in an elemental small time interval dt, the amount of charge transfer differs for different value of instantaneous current, and to find out charge transfer in a considerable time duration, we have to integrate elemental charge contribution given by I dt differential equation, and integration of I with respect to time for specified time interval give us total amount of charge transfer by alternating current. To find out equivalent charge transfer capacity of time varying alternating sinusoidal current, it should be compared with a fixed ideal constant magnitude unidirectional DC current, and this comparison can be done for one cyclic period or time period, as the same cycle is repeated onwards. So anything which is true for one time period is also true for any long time duration. So in one time period duration, steady DCI current produce total amount of charge transfer equivalent to product of current and time, and for AC instantaneous current I in small time interval dt produce elemental charge transfer dq, and total charge transfer can be obtained by integration. And for this one cycle, integration starts from 0 time instant and it is for one time period. So in one time period, total charge transfer by AC and total charge transfer by DC can be equated, and this equivalency can give us equivalent DC value of current which produce the same amount of charge transfer as our concerned AC can produce, and we will soon find that this equivalent charge transfer capacity of AC in terms of DC value is nothing but average value. To find out equivalent charge transfer capability of sinusoidal alternating current in terms of a DC current magnitude, we compare charge transfer by sinusoidal alternating current and direct current for one complete cycle or for one time period. And in one time period, steady DC current capital I in time period capital T produce charge transfer as multiplication of current and time, and at the same time interval in a sinusoidal alternating current cycle, current instantaneous current I when integrated with respect to time in interval 0 to capital T will produce charge transfer given by this integration result. And when we equate these two, we can find out that DC value which transfers same amount of charge as transferred by alternating current in the same time interval. And if we simplify this expression, we got DC equivalent current value for charge transfer capability equal to alternating current is given by integration of current divided by time period of one cycle, and here current is integrated for one time period and this integrated result is divided by that same time period. So we got average value of current, and we can say average value of alternating current is that DC current value which transfers same amount of charge as transferred by AC in the same circuit in the same time interval. So when alternate time varying current is integrated for certain time interval and that integrated result is divided by the same time period interval, we got average value of current, and average value of current is that steady DC value which transfer the same amount of charge as this alternating current is producing. So we can say average current of alternating current is equivalent charge transfer capacity of AC in terms of DC. And for sinusoidal standard current, I equal to Im sin omega t, where Im is amplitude or peak magnitude of sinusoidal time varying alternating current. If we express instantaneous value of alternating current as Im sin omega t and produce this integration for one time period duration of sinusoidal alternating current, then integration of sin omega t is minus cos omega t divided by omega, and after performing integration, the limit of integration, starting point 0 time instant and end is time period of one cycle brought to the backside of integrated formula. In place of this varying time, once we put end limit of time, that is end of cycle, time period capital T, and at second time with change of sign, this minus become plus, and in place of this T, when we put initial value of varying quantity for by which we have performed integration 0 time, then it become cos 0. The value of cos 0 is plus 1 and omega t is equivalent to 2 pi, and cos 2 pi or cos 360 is 0. So this is with minus sign minus 1, and when minus 1 and plus 1 is added, we got full cycle average value of sinusoidal alternating current is as 0. So we can say in full cycle alternating current transfer charge equivalent to charge transfer by 0 value of current, and we know 0 value of current won't transfer any charge. So full cycle charge transfer capability of alternating current is found as 0. This is evident from this symmetrical sinusoidal standard time varying alternating current which have a positive half and symmetrical negative half. In positive half cycle, certain amount of charge transfer in one direction, and in negative half cycle, when direction of current get reversed, the same amount of charge will transfer in opposite direction. And when we sum up the total charge transfer of entire cycle due to symmetrical identical positive and negative half sections, the resultant charge transfer will become zero. So total net charge transfer of full cycle of alternating current is always zero, or full cycle average value of alternating current is zero. So by that fact, alternating current directly is not used in all those applications which involve charge transfer in their action, such as electrolysis, electroplating, battery charging. We use in our measurement moving coil ammeter, which measure direct current with great sensitivity and precision. Now these moving coil ammeter, when measure average value, full cycle average value of sinusoidal alternating current is zero. So the reading given by such moving coil ammeter for alternating current is always zero. To get some meaningful result, we can compare sinusoidal alternating current with DC current for charge transfer capabilities for just positive half cycle, because we know in one positive half cycle the direction of current flow is always the same, though the current magnitude is varying at different time instants. So for one positive half cycle there is a charge transfer only in one direction, and we can find out equivalent DC value which transfer the same amount of charge in positive half cycle or in one time period as charge transferred by DC. And for this comparison we have taken time interval for comparison half of time period, and study DC current when multiplied with time period will produce charge transfer by DC current. And in the same time interval from 0 to t by 2 of positive half cycle, the instantaneous current when integrated with time gives us elemental charge transfer, and integrated results give us total charge transfer in positive half cycle. And we have equated charge transfer by DC and charge transfer by AC for positive half cycle time period to find out equivalent charge transfer capacity of alternating current in terms of DC current. And simplification will result as integration of current for positive half cycle from 0 to t by 2 time interval, and division of that integrated result for the same time interval. And when we integrate current for a certain time period and divide integrated result by the same time period, we get average value of current. So we can say average value of current is that DC value which transfer the same amount of charge as transferred by alternating current in positive half cycle. So here time varying alternating current is integrated for positive half cycle interval from 0 to t by 2 time interval and divided by the same time interval. Then we got average value of alternating current, and we can say average value of alternating current is that DC value which transfer the same amount of charge as transferred by AC in positive half cycle. And in place of sinusoidal instantaneous alternating current I is equal to Im sin omega t, if we substitute time varying expression of instantaneous current and perform this integration, in this t by 2 will come in numerator, and integration of sin omega t is minus cos omega t over omega, and the limit of integration for positive half cycle starting from 0 time instant to t by 2 come after integrated result. And in place of small t, once capital T is placed, and in next time with change of sign t become 0, so this become cos 0, omega is brought out of integration, omega t is equivalent to 2 pi, and this 2 pi by 2 become pi, and value of cos 0 is plus 1 and value of cos pi is minus 1, and with this negation this become plus 1, 1 and 1 become 2. This 2 in numerator get cancelled by 2 of denominator, and in bracket 1 and 1 become 2, and our half cycle average value of alternating current having peak value or amplitude Im comes as 2 Im over pi. So this 2 Im by pi is that DC value which transfer the same amount of charge which alternating current would transfer in positive half cycle. In our studies, we use some periodic alternating signals other than sinusoidal. One is square, other one is triangular, and the third one is sawtooth. In all these alternating signals, there is periodicity and there is a symmetry of positive half cycle and negative half cycle. So in all those, full cycle average value is 0, but As we know, for alternating such signals, average value is defined for only positive half cycle, and for positive half cycle, this square wave got identical Im value all through positive half. So its average value is also its amplitude or peak magnitude Im. Whereas in triangular and sawtooth, the instantaneous value varies linearly from 0 to peak Im value. So average value is half of it. So average value is Im by 2 for both triangular and sawtooth. In examination, straightforward simple numerical are formed on average value. We have given an alternating current I equal to 10 sine 100t, where this 10 is amplitude of current in ampere and this 100 before t is angular frequency in radian per second. We have to find out average value of this current and the total amount of charge transfer in one cycle. So we know such standard sinusoidal signal or any other sinusoidal signal have identical positive and negative sections. So full cycle charge transfer of those signal is always 0. So total amount of charge transfer in one complete cycle by any alternating current is always 0. It also got total amount of charge transfer in one cycle equal to 0. But average values are defined for positive half cycle, and for positive half cycle the average value or DC equivalent charge transfer capability is 2 times of amplitude divided by pi, and amplitude of this current or peak magnitude of this current is this number 10 before this sine function, and amplitude with 10 ampere when it is doubled and divided by pi will get 20 by pi or 6.3636 ampere as average value of this current. So this current having peak magnitude 10 ampere transfer charge equivalent to its average value is 6.36 ampere. In all electronic circuits and systems, we need unidirectional DC current for their operation. We also use DC current for several other applications such as battery charging, electrolysis, electroplating. So for that, we use our conventional alternating current, as all over the world generation, transmission and distribution of electricity is in the form of alternating current. So alternating current is converted into unidirectional DC current using some static rectifier circuits which are conventionally made of semiconductor diode. Now recently, to get variable DC supply, we also use Thyristors rectifier circuit to convert AC into DC. And when single phase alternating current is converted into unidirectional DC current, there are two rectifier way. One is half wave rectification, where the negative half cycle is stopped and only positive half cycle is allowed to pass through the circuit, and we get unidirectional current flowing only in one direction, but in place of entire full wave we will get only half wave in output. So this is called half wave rectification. Whereas in another way, the negative half cycle is inverted in previous direction. In both halves we got current in only in one direction, so this is called full wave rectification. For rectified output, average value is taken for entire one cycle, and for half wave rectified output, this would be one cycle. So output frequency and input frequency is the same, and average value for this is average of positive half cycle and 0, and average of positive half cycle is 2 Im by pi, and when it is added with 0 and divided by twice period, we got average value of half wave rectified as Im over pi, which is half of average value of positive half cycle. Whereas in full wave rectified output, this is one cycle of output which is pulsating DC, unidirectional but varying magnitude, and its average value is the same as average value of positive half cycle, and it is 2 Im by pi, and it is clear that average value of full wave rectified output is 2 times of average value of half wave rectified output for same amplitude or peak values. Now this value of average value of rectified output is used in all our rectifier circuits, and when we use rectified alternating current in electroplating, electrolysis, battery charging or other similar applications. We hope this beautiful learning video has explained each and every concept of average value of alternating current, and now you understand that average value of alternating current is that value of direct current which transfer same amount of charge in a circuit as transferred by positive half cycle of alternating current. Our other learning video of the same playlist are equally useful. You can use them in your studies and also share them to your friends. This will enhance your subject understanding and exam score. And if you need dedicated exam centric notes or online doubt clearing classes from our channel, do join our YouTube membership. Happy learning. Have a nice time. Thank you very much.